it out on a journal and put that disk and get actually more up-to-date information as well.
Sounds a lot more like the database transaction log or something.
Yes, they are. I don't know which journal policy can support that capability. If that was a concern you want to check.
I believe when they direct the actual data out, they're writing on the data, the actual directory itself. The data is one file. You have a lot of files, you decide to replace the middle of 200 megabytes right into that. They're not going to change the file structure, the directory structure at all. So that's what they lost in the file cache.
Yeah. The details of that I really don't know. My understanding has always been that that journal file systems really don't offer any much more protection than the regular file systems. But the goal is always to improve the recoverability
and minimize the chances of corrupt directory structure. Right.
Okay, let's go ahead and move on. Product lifecycle management piece. This is what another, usually you have a capacity group in your company that does the same thing, and they help you manage the lifecycle of your PCs and your software ages, your hardware ages, your operating system ages. You've got to be able to manage all this stuff. Like I said, you don't deploy 1,000 systems 1 week and then do it again 2 years later. You've got this whole process going, so you've got to have people who can watch that, that your compact machines are out of warranty next month, and make sure you've got something in the works to get those replaced. Vendors make improvements to release new stuff, stop supporting old stuff, and when they do stop supporting old stuff, your SLAs are at risk. If your system crashes, you call your vendor and they go, oh, we don't support that anymore, you're not going to be able to meet your deadlines because they're not going to come in 2 o'clock in the morning and fix hardware they're not supposed to support unless you're paying big bucks. So, maybe that's the way you're going to meet your SLAs. You'll pay tons of money for support that you shouldn't have to if you were a manager of Lifecycle. Let's see what else. And we all agree that buying cheap PCs with a month is not feasible for any enterprise. So this whole product lifecycle management is really an art that balances, the cost of your systems with the longevity of your hardware.
We've got a section on enterprise class hardware later.
I think so. Go and bring it up in a minute. Don't deviate from the plan.
Stay on target.
All right, this is my favorite topic, root cause analysis. I could go on for at least a minute or two on this particular topic. Root cause analysis to me is that when I have a system fail, I've got procedures in place so that I can find out exactly what caused that failure. And that's the nice thing about big vendors like Sun and IBM. They pretty much have got it nailed down to a science. But if your system panics, you can retrieve core files, console output, any number of other clues and stuff from the system crashing, that when you bundle all that up and send it to IBM, they could pretty much turn it around in about an hour or two and tell you exactly why your system failed. And usually they'll come back and say, I don't know what happened, but you need to upgrade your kernel patch. You need to upgrade the latest kernel, the latest systems. We can tell that you don't have the latest security updates. That do that first and see if the system fails. And another one of my topics down here at the end is the actual vendor management piece, and that's when you have to yell back at them and say, no, you go find the guy who knows how to do this stuff. And you have him give me an answer.
Because we've got 50 other machines at the same level, and they're not having this problem.
Right. So root cause analysis is the end all to me of real enterprise computing. If there's a situation where I can't find out what caused the problem, then that system does not belong in my data center. So, how do you identify exactly what happened? Was a memory leak, poor performance, system panics, all those topics deal with root cause analysis. Some of those tools like the monitoring tools or the pieces that detect the landmark or those kind of things, those things can help you because they'll tell you, as the system runs almost real time, or give you a quick, history. They'll tell you what processes are taking a swap and stuff like that. So in those cases, you've got better tools. But in the case of Linux, if you have a kernel panic, my understanding is that there is still no true core dumps for Linux. They do dump things to the console, these little oops messages. And that's a big improvement because they used to not even have that. The system used to just go blink and reboot. Now, granted, it didn't happen very often, but still, if it does happen, you need to have some type of a response and how to deal with it. So let's see here. Identify what clues and evidence are required. So, you need to know what it takes to come up with your root cause. And then, of course, you have to remember what your SLA is. You got to remember, who's your guru, and how many gurus do you need. If you run a shop that's 24/7, you're not going to have the same guy being your guru all the time. You got to hire a lot of these guys. Kernel core dumps are often overlooked. I already made that point. Native Linux kernels do not have core dumps, and most importantly, faults in the kernel reports are often lost in the system console. System crashes, makes that nice little oops file, but then continues to reboot. You've lost the key components of your clues. Yes?
About kernel core dumps, I think some people at SGI did something, but it's not in any of the standard kernels that anybody ships as far as, maybe SGI does on their own hardware.
And I'll tell you why. Core dumps are a very complex piece, and every time you upgrade a kernel, you change the boot system map file, and you change other things in, that associated with the kernel. And so when you submit a core file to some vendor to look at it, you not only have to send them the kernel, but you have to send them the right system map file. And for people who upgrade their own kernels, a lot of times they just take a kernel a day, compile it, and install the image to boot with, but they don't upgrade the system map. Because usually if you're not changing major versions of the kernel, you don't have to deal with that, except in certain situations. And so if you don't align those properly, it's a big mess. And there's other problems with kernel core dumps. But you're right, SGI has been working on it. I went to a Linux World presentation from the gentleman who was doing it, I think it was about 2 years ago. And it was good stuff, but it does require you to build your own kernel, patch it, and install it. And right away, once you build your own custom kernels, now you're at risk with all the people who are supporting your regular Linux for saying, I'm not going to touch that. So one solution to help you kind of retain your oops messages on the screen is to perhaps configure your kernel to dump those messages to the console. Console being a serial port. And hopefully, if you're in the data center running or reading at home, you have your serial port connected to another PC that basically logs all the input to a file. That way, if your system crashes, you go to your alternate PC, and you can go capture that input there and then send it to your vendor for a quick peek to see what's going on. Okay, so the serial console can help. The Linux kernel definitely supports serial consoles. Live supports serial consoles. And those are kind of the steps in the right directions with this KSIM oops. And there is a utility also that maps oops data to an actual human readable, this process killed your box. So steps in the right direction. If it's the right solution or if there's a real final solution coming, I don't know yet. But this is my hottest topic with Linux in the enterprise. Because this is what I do for my living. This is what I do for a living. Because I don't analyze core files, but I gather those clues and send them off to vendors. So my job is to motivate somebody else to tell me what caused my system to crash. Okay, and this is of course the big total cost of ownership, or TCO. If you're talking to any business partner, that's their bottom line. How much is this environment going to cost me? So, you got to consider your one-time versus recurring costs. Compact costs more support than IBM, or HP costs more. These are all things that help you decide whether you're going to buy an IBM or a compact. It's not always just performance. Application consolidation might help. This is where if you have 10 systems that are all running Apache web server, but all your 10 systems are idle, maybe you have all your web servers run on one system. So consolidating all your applications onto one box. How about server consolidation? This is the IBM's big forte these days. They're trying to convince companies to take 10 PCs and put them on their mainframe. So basically now you're taking all this equipment and consolidating onto a single frame machine. And you can either do that through hardware, where you're abstracting, or creating these logical partitions, or LPARs in the IBM terms. If you're a Sun person, you're creating domains. But these are other things you can that you have to consider. And then, of course, the last piece here, these virtual machines. Virtual machines, anybody not familiar with VMware? VMware is a great, awesome product that basically allows you to run a PC inside of a Linux machine. You install VMware, basically boot it up, a little box, looks just like a PC, a little BIOS thing that comes up, and then you basically tell it, go install Windows, and it installs Windows inside of itself. And you can run Windows inside VMware. Well, you can install multiple copies of VMware in your box. So now you can have your one system running Windows, Linux, anything that runs on a PC inside these little VMware sessions. The company that produces VMware recently introduced a number of enterprise class VM solutions. So no longer do you need to run VMware on or inside of a Linux thing. Now you can run it in its little mini OS, which basically improves the performance of the VMware tons. And it also allows you to scale more slices per box. My understanding is that the latest version of VMware still will not show any one slice more than one seed. It basically replace any piece of your enterprise. The jury's still kind of out on that. I was kind of hoping to open up a little discussion here to see what your comments are, if anybody's got experience with deploying Linux in the enterprise.
Touch a little bit about what makes enterprise class hardware in a hard-end machine.
Well, we did mention the redundant power supplies, the hot swap disks, and that we touched on that. But.
How would, let's say, serverless scale compared to Linux?
Well, if you look at like a 15K or even the new Sunfire boxes, I think those scale up to like 128 CPUs or more. That's what I'm saying. I think the 10K was 64 CPUs. So, again, you got to consider whether or not your application will make use of that. Not every system's going to be able to, depends on the threading and the way that people wrote the application.
I don't know pricing for the 15K, for the Sun 10K, we're running $1.5 million. So we have to determine whether you need that level of performance or not.
The 10K also offers that whole domaining concept where now you're at the, almost at the BIOS level, you're saying that these CPUs are one system, these CPUs are another system. You carve up your memory, saying this memory belongs to that one and this one. And then when you start your system up, all these OSs are running on the same physical frame, but they're really oblivious to one another because they don't realize that they're all running on the same OS because you divided the hardware at hardware level. The IBM S390 does the same kind of thing, where they create these LPARs, or logical partitions. So at the microcontroller level, they go in there and they basically turn off and on CPUs and then bind them to particular LPARs. And then you can run Linux on a native S390 LPAR, or you can install the ZDM piece, which allows you to run as many copies of Linux as you want. So basically, with microcontroller, we go in and say these 10 CPUs belong to LPAR 0. I'm running ZDM. ZDM now can bring up any number of virtual machines or virtual versions of Linux on it as you see fit. So, good stuff.